Welcome back to the Wizards Lab. And today we're going to actually use the Java and the Eclipse that you installed last time. And with that, we're just going to open our Eclipse program. Usually will take a little while before it comes up, but when it finally does, you'll have something that looks like this. May have a welcome screen on it, and you'll see that in a little welcome tab up here, like where this says Package Explorer. There might be one like right over here that gives you welcome or something like that. Just hit that X, get out of it until you have something that looks like this. So the first thing we want to do is actually create a new project. Eclipse is designed actually for, you can make very large scale projects for enterprise wide things. Like if we were writing a new student information system for the entire college or something that may have many files and other parts of the package all in it. It's kind of overkill for simple things, but yeah, you got to start somewhere. So we're going to learn it as we go. And by the end of the program we're doing, you will have more to do. So let's get started with this. The way we'll do it is we come up here to the top corner, and yeah, this way. I still have to learn my weather mapping way of doing things, so it's backwards from what I would think. So up here, File, and we say New, and come over to Java Project. So we're going to create a new project. And if you followed the instructions in the last part where we click the little box that said always use this location for our default files, you can keep the little box right up here check that says use default location, but we have to give it a project name first. And our first thing we're going to do is hello. Just no matter what program you're learning, what class you're going through, your first program is usually called Hello World, and that's just to make sure that your development environment is working right, the compiler works, and you can just get in there and it accesses everything right. And so that is our purpose of today's lesson, is let's make sure it all works. So when you do it, project name right here, let's make it say hello. Use the default location. You should see very lightly in here is the path of where you said to put it, and then put a /hello on the end. It's going to make a directory within that directory just for the files associated with this project. Now, come down right here and to where it says project layout. And this is where it's going to store the files in there. For ease sake, check the box that says use project folder as root for sources and class files. With this, so I put all the files neatly together. Otherwise, it creates separate little folders under the source, and one's under resources, and then the output, and it can't find things unless you put them in the right places that it wants you to put things. Once again, it's overkill for what we're trying to do. We get into doing, it doesn't matter much at this level, but when we start handling files, it's nice to just put them all in the same folder for your input and output files right there where your source code is and the class files. And you'll learn that part later. Just for now, make sure you can check this box. If that is grayed out where you can't change it, it has something to do with the default location stuff up here. Because when you uncheck this use default location, sometimes it will gray this out. So if that's the case, say use default, check it, and then you can go back and change if you need to. But for right now, if you set things up the way I showed you in the other video, then you will just be able to use default location, click this box. We don't have to worry about anything else right now. Just hit finish. When that happens, we can come over under file. Let's see. No, let's go window. Let's see where it kind of hides these things on us. I'm looking for one. There it is. Under show view, come down to Project Explorer. Right, and there's a Package Explorer and a Project Explorer. I like to have the Project Explorer. Adds a new tab right up here. And we can see all of our different projects. Right now, since we're new, we only have the Hello project. So click on him and it will have anything dealing with that project. Let me go this way. There we go. That project all right listed. And this is stuff that it's adding in automatically in the background for stuff we don't need. But what we need is our source code, and that's what it's waiting on for us to do. So part of that, we can come up here now, see File. So this is step 2, New, where we went to create a new Java project. Drop straight down to Class. We're going to make a new class. Under that, it pops down automatically here to say Name. And we're going to call him Hello as well. And best idea, the standard way of doing Java, the standards say, put that name with a capital letter. So anytime they're creating a new Java class, start it with a capital letter. And the use of default package is discouraged, it says. We don't care. We're going to do it anyway. Once again, this isn't this big stuff. So ignore his little warning message. Now, if it's red up here, it means there's some kind of error. And depending on setups, it's going to make you name a package here. But we're going to use the default package. And hopefully he'll be happy. We'll see later. Dropping down right here, which method stubs would you like to create? We're going to check the first box. We want to create the main for us and uncheck the others. So that's the only one that needs checked, is that very first one. So we give him a name here. Leave the other things alone, hopefully. Check that box, uncheck anything else, and hopefully he'll remember this from this point on, that this is what we want. If not, just verify that. And then we hit finish. With that, he goes creates our project. Well, he's created the project, but now he's going to add to that. There we go. We've got hello.java as our Java file, and it's just this extra breakdown stuff on it. It says, okay, within this directory now we have a hello class and a hello Java. The hello Java file displayed over here inside of our editor portion now. So now we can go in and change anything we need to. Technically, this is a working program right now. If we were to run it, and we can do that with this little green circle right here. It's got a little play button on it. You hover over it, it says run. There's other options for things. Debug, run. Right now, just the run. It's going to pop up. We'll have a little... Yeah, well, guess what? He didn't have anything to do, so, okay, I'm done. All right. Now we want to actually do. We're going to click right in here where it's got this to-do part. Just click right there. And hit the tab button and move over inside of here. And we're going to say system.out.println. And so he's giving me some hints on some things that I could do in here. So we'll get into that part later. So open some quotes and say, hello world. And we end the quote in the bracket and put a semicolon. Mine's trying to help me. Oh, I got a mistake. Then you can just click right in there, backspace, put the right letter, and we've got a line of code. And so it's kind of color coding some stuff along the way for us. We'll get to all that part later. But the part, you got to make sure that this first one, system, make sure that it's capitalized. The other parts are not. Dot out dot println, short for print line. And hello world. And when we run it, once again, right up here, hit that run button, it's automatically going to, well, first time he pops up this box. Oh, do you want to save this first? Yes, please do. And just right now, go ahead and hit this box to always save it. So anytime I hit run, just go ahead and save it for me. You don't have to ask me again. So we hit OK. And now if we look down here, we've got this little thing that says console right here. And here's some words. Hello, world. Gee, that miraculously matches whatever we pointed out right here for it to say. And so, boop, there it is. And just to prove, if I say change this from hello world, and I said hello Fred. Oh, my big fingers hit that caps lock button sometimes when I reach for an A. Or the shift. That was probably the shift at that time. Hello Fred. So if I run him again, watch down here, he now says hello Fred. Now, I don't normally like my console down here because I'm up here and it's just real little, and if I get into a lot of writing, I can't see much. So I can click on this part here and drag that up here. So put him right next to here. Now, I can switch over here, look at my code, switch here, and look at the output. Code, output. So now if I'm over here and if I hit run, boop, it'll switch to the output automatically. And it says terminated and stuff up here. It reached the end of the program. It was done. And here's the output. And so if you get that, you've got a working program. Yay! If not, you may see some things over here. And notice now I've got this little red X right here. If there's anything red in this column, that means he ain't gonna run. So if we hover over him, it says syntax error. That means you have a typo. Something is wrong. You used the wrong command, the wrong words. You left something out. He's going to give you a hint. It says insert a semicolon to complete block statements. So I come in here, put a semicolon, and that disappears. He's all happy. All right. Now, what is that semicolon for? Well, in the English language, what do we use to end a sentence? Well, you can use a period or a exclamation point or a question mark, depending on what kind of statement you're trying to make in the sentence. Boop. Well, in the Java programming language, along with the C programming language that Java is based on, use that semicolon, ends that sentence. And so with that, again, we've got a program. So now let's talk a little bit about what we're doing here. Let's see. For those who've had my class, we've already talked about the machine language and the binary. And for those of you listening on the videos, I'm going to go back and make another one of those. So number 3, episode 3 will actually be my second class, where episode 2 is at my third class. We're going to switch y'all up on that part. So we'll talk about the binary and how computers think and needing the ones and zeros for that part. But meantime, let's see. I'm going to pull up our chalkboard here. And as we talk, I like to write and do pictures and things as we go. So basically, once again, how does a computer think? What does he think in? Yeah, ones and zeros, because what are those? Electrical impulses, ons and offs, whether it's got something there or not. And it combines those. Let's see if we have, 8 of those. that would be 1 byte of something. Another 8. 1, 2, 3, 4, 5, 6, 7, 8. Right, these guys here. You can't see my cursor. There we are. 2, 3, 4, 5, 6, 7, 8. That would be 1 byte. Another byte. 1, 3, 4, 5, 6, 7, 8. Another byte. So the memory locations, we would put 1s and 0s in, and that's how the computer would know what to do. We don't want to have to try to read that or write that, converting our thoughts into 1s and 0s like the very first computer programmers had to do. No. So they went out and made some other things for us. Actually, something's going on here. There we go. Put them back. Let's see. They create. Well, wrong screen. That helps. They started making some stuff called assembly language. Anyway, and it was. Let's see. If I pause here. Okay, as we're looking at some sample of some assembly language, let's see, we're gonna, whoop, here we go, poof. And, all right, move EAX, 3, move EX, EBX, 4, add EAX, EBX, ECX. So what it's saying is like a memory location that we're gonna keep up with somewhere, a register, they were calling it. You're going to take the number 3 and stick into EAX. Take the number 4, stick into EBX. Now, we're going to take whatever was in EAX and EBX and add those together and put into ECX. So you had to keep up with what memory location names and you were dealing with, and yeah, we didn't like that. So there's some business people that didn't like this. And most people who were programmers at that time were actually math majors. We didn't have computer science majors yet because we didn't have computer science. We had some people who developed some computers. Now what? And majors math people who went out and created the programs for us. The business people needed something in the business world, so they created something called COBOL. It's a business-oriented language. That's what the BOL on the end stands for. I forget what the CO stands for, but actually my first internship in college was actually programming in COBOL over the summer for a company down in Houston. The next summer I took my COBOL class, and actually, well, I got an A in it because I've already done this, but now let's get some credit for it. COBOL being business-oriented stuff, if you could write an English paper, you could write COBOL code. It would be something like add 5 to X or result in X, period. So what is it? Whatever was in X, add 5 to it and put it back into X. Let's see. From there, we had the engineering guys decided, hey, let's do things a little bit better than that, but in mathematical and engineering style ways. So they came up with Fortran, which was for formula translation. So they're going to write formulas and have it translate that into computer code for us and do stuff like that. Not used very much anymore. There are holdovers from Fortran actually in spreadsheets. When you use your spreadsheets with Excel and things, you start playing with things and you'll find out what those are. See, basic. That one came up with pretty straightforward language. It's almost, if you can think it, you can write it a little easier that way. That's what my old Commodore 64. you turn on the Commodore 64 that I got when I was in 8th grade, 1983. So, yes, I'm that old. Um, there's stuff was there for basic, and my mother, instead of buying me games for it, let's see, well, instead of buying me the games to play on the Commodore 64, she actually bought me the books that's got the programs in it. So now if you wanted to, let's see, let's do this page. There we go. You wanted to play the game, you actually had to type the programs in first. And so there's some basic code. And you type all that part in, and you're ready to play the game. Yep, that was all the game right there. There and there. That's to do states and capitals. So that from basic. Let's see. They actually developed a teaching language, one just used for teaching computer stuff, called Pascal. But people started using it in industry anyway because that's what they knew, because they got taught that. So Pascal, and then there's kind of a form of it that I call it Pascal++. It's called Ada, which is actually just used by governments, by the U.S. government for government programs. So they're writing stuff for NASA. I know there's guys down in Palestine campus for NASA that they want Ada programmers to program stuff for the tracking and stuff of weather balloons and things like that. So the same kind of stuff that you'd have for space shuttle, anything else going on at NASA, it's mainly going to be written in Ada. And there's no reason for it, but it's kind of based pretty much just like Pascal. Let's see. Then in the 80s, they developed a programming language called C. And that's actually the basis for many other languages to come later, such as C++. And what that is, you're going to take here, let me go off here for a little bit. Let's go back up here. When we're talking to COBOL, see how we do this add 5 to X and store result in X? Well, engineers came up with the others, I told you, with the Fortran, and developed from there into the C and C++. Well, what they came up with, they didn't like being as wordy as this. What they can do is say X equals X plus 5. So that is the same thing in C and C++ as this line in COBOL up here. Right there. A lot simpler, right? It's because I was telling the class earlier that programmers, well, engineers are lazy. Really. I said, yeah, we put all this hard work into everything so that we can be lazy. Because what it is, as an engineer, we learn how to do something one time. And from there, we're either going to make a machine or write a program to do it from that point on. We don't like the assembly line. We're not going to work on the assembly line. We create the assembly line, maybe. You know, we see what's going on now, let's automate it. So it'll do it the same way every time, take the human error out, and do it where I don't have to stand there and do it. So we're going to let it do it instead. Shorten things down as much as possible for it. As I told them earlier, like one day there's a engineer, he stayed home from work one day, and his wife still had to work. So he said, oh, she said, when I get home, you know, please at least vacuum the house. And so he went around. So before she got home, he got it all clean and everything. He saw how to do that, but he said, okay, I'm not doing that again. And that's why we have Roomba vacuum cleaners now. So there you go. The engineer will figure out how to do it where he doesn't have to. All right. Also, there's another way of doing this. What do we have, like X equals X plus 1? That's something we do quite a bit often in our programming, is we're going to do things one step at a time, and we're moving down the line doing it one at a time. And this became uh, a very much used phrase there with x equals x plus 1, using our variables. Uh, and knowing engineers, what are they? Lazy. They don't want to type that much. They sure as heck didn't want to type this much. But now they're going to say, even that, yeah, there's something else we can do with that. How about x plus plus? What that is, that's the same as saying x equals x plus 1. So whatever x is, add to it. And so that's incrementing x, we would say. So all of this can now be this. And if we go back and look at the language, boop, here, C, a guy came along with the C programming language and said, okay, let's add to that. Let's make it better. And created the C++, making it object-oriented. And that's how we get the plus plus on the end. And along comes Microsoft. And they decide they're going to make C++, and with another plus plus onto that. Which it's a little hard to do on typing. But if we're going to take C++, and we add that all together, and what they have now created was C#. If you see that in that little plus, and put them together forms the little sharp sign. And no, it wasn't such a great idea. The reason why they did that is because a company called Sun Microsystems had come along at this point, and the internet was coming out to public use. It had been technically available since the 1960s with ARPANET, ARPANET, with DARPA and stuff like that, connecting military stuff and universities where they can send information between each other as they're developing weapons and all these kind of things, right? And the research, and well, it became accessible to the public in the early 90s. And with this, well, you had computers that were running Microsoft, and most of those were at DOS at the time, and they were starting to run Windows. There's that Windows 3.11 was the first one to add networking at that point. And soon after that was Windows 95, which started adding everything else that we now do in the graphical environment. But also available at that point in time were the Apple Macintosh, stuff that we would call a Mac now, from the Macintosh, a type of Apple. Luckily, they didn't call it a Fuji or it's not the Apple Granny Smith. So, the Macintosh. Also available at that point in time, was the Unix machines. These were very much more higher end servers, more stable operating systems than anything Microsoft ever thought about doing. And so you had HP that were creating them, along with Sun Microsystems, a few others out there. And what happens, these machines being pretty stable environments. When I worked at Texas Instruments in the semiconductor manufacturing, we had several Unix hosts that were running our software, some of which these servers had not been rebooted in 5 years. They were that stable they could run for 5 years without being reset. Try that on your Microsoft machine at home. Nah, not going to happen. Also, at this point in time, they had come out with a new operating system using the Intel processors that are used by Microsoft and later by Apple. They also came up with new operating system called Linux, which was Unix on the PC hardware. So you didn't have to have the big expensive Unix machines. You'd use a less expensive PCs and run Linux on them. And with that, you had a company called Red Hat that was kicking out, let's spell that right, Red Hat, kicking out a version of Ubuntu, came up with their version, and from there it diversified. You'd have ones like CentOS, which was based upon the Red Hat. They released some code and they went with it. That's the Red Hat version that others will build upon there. Different things like that. I forget all the different names that are out there with it now. Oh, wait, yeah. See, SUSE Linux was one of the yeah, there we go. SUSE was one of the popular ones, had a little penguin and stuff on there. But the trick is, when you write your code for any of these other languages up here, in C, C++, even the C#, you run it, you compile it on one of these machine types, it will only run on that machine type. Because it takes from that human readable stuff, or pseudo human readable, our code, and puts it down into the ones and zeros that the machine needs. And at that level, that is specific to the hardware of those machines. And, well, you can't do it from Unix to make it run on the Windows or even onto the Apple machine. That's why when you go to download the stuff, that's why we had to make sure we downloaded the right version of Eclipse even, or download the right version of Java for the right version of the machine. The revolutionary part of Java is you write it once. The code you write for the Mac can run on the Windows machine. You can run it on the Unix machine. Because it doesn't actually, when you compile it in our development environment, that's what, that when you downloaded the Java SDK, Software Development Kit, it downloaded parts that now you're going to use in Eclipse that takes what you write, compiles it up into a generic format, like 85% compiled. And then it's going to run it in a virtual machine, the JVM. That's part of the development kit you downloaded, was the JVM. There's a different version of that for each machine. So now your software goes, it runs in that little piece of the JVM, depending on which machine you put it on, to finish up for that machine. There's a few little differences that may keep it from running on the different machines. The program we just wrote, the Hello World, should run on anybody. And later when we deal with files, the way that the file systems work between the different operating systems are different. And so that's where I'm saying we need to make sure we're running the Microsoft because that's what I'm going to be teaching to. If you want to do the Apple, understand there's going to be some changes you'll have to make in the way that we name the files and access the files in order for it to work. But that's a rundown of what the benefit of using the Java is versus any of the others. And with that, let's see. Let's go back now to our development environment. All right. That was a brief history of computer programming, language development. let's look at the actual part we're doing here. See what's going on. Our main program, see, we start off, we say public class hello. And that's because our program is called hello. And so our class file, this name has to match the name of the Java file. See Java hello.java. Move the thing and the public class hello. The class name has to match the name of the file. And that's how it knows what it's doing when it compiles everything later. This being our primary file for our program, you can make other files that we include into this one. We'll get into that part later, trust me. Not today. But being that one, there's one special function we have to add in. A function is a program within a program that you call, you can call multiple times from the thing. It's like if I want to call somebody on the phone and I do call, I say, okay, here's what to go do to call somebody. And I can call them again, and I can call them again, and I always do the same steps. I can have a function that can go do that for me. In this case, the first one we do, no matter what, is a function called main. It has to be called main, because that's when he runs. He says, "Oh, okay, where's main? There he is. Go grab the main," and that's where we start running our code. He can call and do anything else from there, but he has to be there. And when we do it, he has to look just like this. That's why we told him to go ahead and create this function for us with that little checkbox when we say create the new Java file. So yes, we're going to have a main in this one. Make him the main and generate this for us. So public static void main string array arguments, or args. And from there, we have these little brackets. He likes to put them this way. I like to put them this way. And we'll discuss that here later. Whoop. Here. Whoop. Okay. And Java is open to your format, however you want to format this stuff. It's your code. He lets you format how you want. Some of those others we had talked about before that were very specific. This column must have this. This column must have this. Yeah, that's the Fortran and the COBOL, the early ones. Some of the basic. Well, you saw on the basic, there's these line numbers, and it'll execute in order of the line numbers you put in the front. And they have to come here, and then there has to be spaces, and then this part here, and if you don't follow that format, it isn't going to work. Java, they're like, once again, we're engineers. We don't want to be that tied to something. We want to be creative. So we're going to do it this way. So the trick is, so any brackets you open, you have to close. And so anything within this set of brackets, that's going to be part of the class called hello. And we just open a bracket and we close a bracket, and everything in there will be part of it. I like doing it this way so that I can line them up. There's one here, go straight down, there should be one to close it. For my public static void main, there starts here, comes down, closes it, and they match. The way the compiler does it, usually, if it does it for you, puts it over here. So you can say, okay, we start the public thing, okay, we ended it down here. But what if I missed? I don't want to have to look over here everywhere and then over here to see where it is. Just put it over here. Lines it up. Yeah. It lets you do it. It doesn't take up any more memory or resources of your computer to put another line in. Believe it or not. That is so negligible, and when it compiles it, it will compile it the same way. because it's turning it into its own code anyway. All right, so watch this. When we run this program, we're going to run everything within these two brackets. And right now, we've got this line that says to do auto-generated method stub. And this little slash slash. What that little slash slash means is ignore everything after these little marks. Those are called comments. You can leave yourself notes all through your program. And actually, the more notes you leave to yourself, the better. Because also, you got to leave notes to me in your program. So when you're doing something, you want me to know what it's doing. You want other people to know what your code is doing. Why? You might not always be around to support your code later. You're working for a company and generating all this software, and later you get a new job, you move off, somebody else has to come in and support your software. Very rarely in industry are you going to be starting from scratch and creating a whole new program. This company has been around for 30 years. Guess what? They have software that's been around for 30 years as well. They may have updated some in the meantime. So, okay, you might only be dealing with a 5-year-old software, or the guy that was here 6 months ago on a contract and his contract ended. Here's a bunch of stuff. Go fix it. Add this functionality to it. That's usually what you're going to be doing, is add something new to something existing. And to do that, you need to be able to read it and figure out what's going on. So don't write cryptic kind of stuff. Some guys will be out there, let's see how cryptic we can make my code, how compact, and so, no. It doesn't take any more resources to make it human readable. Do it because, once again, you go on vacation and come back, you won't remember what the heck you were doing before vacation. Leave yourself notes, and it can be right there in the code. Label things where you can understand it. That's my #1 rule. Make it readable. But these little auto-generated ones, they're not really needed, so we can actually just take that out. And if you're wondering, what the heck did you just do? Let me put him back. All right. I just moved my cursor up. You see my little cursor moving around here. I moved him up to that front of the line. And I held down my shift button and hit the down arrow. And that highlights that line. With that, I can just hit the delete button, boop, and he goes away. And you say, oops, I didn't mean to do that. Until now, most people don't know the shortcut keys. Do you know about cut, paste, let's see, copy, and undo? And those are all right down here at the bottom of your keyboard. We do, let's see. I'm going to say, first, where I just took things away by accident, I can hit Control Z is the undo. See, there he is. Control X is the delete or cut. So if I say oops, bring him back. Control C is copy. And there's Control V is paste. I can put more of them in. So whatever you highlight, you can cut, paste, and say, oops, I didn't mean to do that. Control Z takes away whatever you did. How's that? So let's bring up my chalkboard again here. And let me erase my chalkboard. So what we can do, TRL Z. I just had, if I can hit the first of it, I can either hit the shift button with the end, goes to the end of the line, and I hit Control C to copy. Control V to paste. We're going to do that 3 times. We're going to just take off the... Oh, that's not what I want. Go away. Somehow did hit a different combination mistake. All right. Control X, C, and V. And what that's going to do, Control Z, is undo. That is your best friend right there. Get used to calling upon Control Z. It's nice, handy right there in the bottom corner. Undo, undo, undo. That's a cut or delete. Copy. And paste. So remember these guys. Now there's another one we can do. Control A. Let's select. Oh, that's what I started using not too long ago. So if I hit Control A, that just, you can't tell much on there, but that just selected everybody. So now if I hit Control C, come down here and hit Control V again. Hey, see, I just copied everybody. You start doing some programming stuff, that's going to be very handy at certain times. So get used to playing around with that. I say, oh, I don't have to do that. I can just Control Z, and he's gone. So remember these guys. Very, very handy. And then another things, your daily usage. Control P. That's print. If you don't want to come up here and hey, where's my you have to file, print here, bring up this, click, 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 click. Control P, print. It works in just about any program, other than your games. You don't need to print where you are in World of Warcraft or anything. All right, with that, let's see. Ooh, I got too many programs open to switch between. I say, with that, you've got your first program going, things to start moving around on. Next, I say we're going to go in and work on our binary, how a computer thinks, and come back and talk about things here on programming and getting us started then on how to create a program and what all this other stuff means. In the meantime, y'all enjoy yourselves, and we'll see you at the next episode.